Good day, class. The last section of the book we are covering before the end of the year. Scatterplots. A scatterplot is a graph that relates two different sets of data by displaying them as ordered pairs. So remember when we drew lines, we had the slope and the y-intercept. It's very similar to that. We have your x and your y. Okay, so you're going to be plotting points just like that. Okay, most scatter plots are in the first quadrant of the coordinate plane because the data is usually positive numbers. Okay, it's real data. Okay, well, you can use scatter plots to find trends in data. The scatter plots below show the three types of relationships the two data sets may have, and you know these. Okay, the first one is a positive correlation. A positive correlation means that if you were to take 2 points, okay, and draw a line, you're going to have a positive slope. Okay, so positive correlation means the slope is positive. Okay, as x increases, okay, so does the y value increase. So it's positive. They're both a positive correlation. Okay, the next one's a negative correlation, and if you were to draw a line, you notice the line goes downhill, and we know that's a negative slope. Okay, so it's a negative correlation. As our x increases, the y value actually decreases. Okay. An example of that would be, so the more time you spend training, which might be your x-axis, okay, the faster your times are going to get, which might be your y-axis. Okay. So back over here with the positive correlation, you can look at it, the longer you work at a job, the more your salary will go up, okay, most of the time. All right, over here, the last one is there's no correlation. You can see the dots are all over the place. You can't connect them. They're not grouped together and going in the same direction. So this is no correlation. An example of no correlation is the longer you do your homework, the faster you're going to run a mile in. Okay, one has nothing to do with the other. Okay, that's a no correlation. Okay. All right, so here's some data. We have a table here. It goes over the altitude, so you have 0, 500, 1,000, 1,500, 2,000 feet. And then we have temperature, okay, which is here, okay. Now we're going to put this information on a graph, and I went ahead and already put my x and my y coordinates on there, so it'll make it a little easier, okay. The easiest thing to do is when you're working with these is this is going to be my x value and temperature is going to be my y value. Okay, so what I'm going to do is I'm just going to plot the points. All right, there's my points. And if you can look at it, this has a negative correlation. Okay, so as the altitude increases, which is my x value, as the altitude increases, the temperature decreases. So they're opposite of each other. So that's a negative correlation. Okay. That is how you graph a scatter plot. All right. Let's look at another one. Okay. All right, this one is you're going to make a scatter plot of the data and the table, and then it asks you what is the approximate weight of a 7-month-old panda. Okay. All right, so I went ahead and made their x-axis. Okay, that's something you're going to do. I went by 2s. Okay, and I skipped just so I could get all my numbers in there. All right, I'm going to go ahead and plot the points. So we have 1 and 2.5, which 1 month. Okay, again, this is going to be my x value. Okay, and then weight's going to be my y value. Okay, at 1 month, the weight was about 2.5 pounds, which is really low here. At 2 months was 7.5 pounds. Okay, 3 months, 12.5. Okay, 4 months, 17. Okay, that's going to be in there. 6 months was 24. Okay, 8 months was 37. All right, 10 months was 49. Okay, and then 12 months was 54, which would be over here. Okay, so this one, positive or negative correlation or no correlation. Okay, this one is a positive correlation because as the age of the panda increases, okay, so does the weight of the panda. Okay, so this is a positive correlation. Okay, the question asks, what is the approximate weight of a 7-month-old panda? So here's our graph. 7 months would be right here. Okay. All right. So we're going to follow it. Okay, you can draw a line if that helps. Okay, I'm going to draw, it's called a trend line, but you can draw a line from the start, okay, to the end. Okay, and 7 months follows 7 months up. Okay, and they're going to meet right there, so about 24. Okay. It's going to be a little over 30 pounds. Okay, so my guess is 30 pounds. Okay, and if you were close, you're fine on that. All right. Okay, another causation is when the change in one quantity causes a change in the second quantity. Or correlation between quantities does not always implies causation. So remember, correlation is positive correlation, negative correlation, or no correlation. And that has to do with where the points are on the graph. If it's a line going uphill, it's positive correlation. If it's going downhill, it's negative correlation. Okay, and then if there's no order to it, then there's no correlation. Okay, now causation is when you change one factor and the other one is going to change. An example might be the more people you have over for dinner, the more dirty dishes you're going to have. So an increase in the people are going to increase the amount of dirty dishes you're going to have. Okay, so that's also a positive correlation. Okay, an increase in people, increase in dirty dishes. Okay, let's look at A. The number of loaves of bread baked and the amount of flour used. Okay, so if we increase our loaves of bread, okay, so if we increase our loaves of bread, okay, what's going to happen to the amount of flour used? Okay, where it's going to increase. So this is our positive correlation. Okay, and now what we need to do is, does it have causation? If one increases or one changes, does it change the other one? Okay, if we decrease the number of loaves we have, are we going to decrease the amount of flour? Okay, and the answer is yes. So this has causation, or causal effect. All right, let's look at the next one. The number of mailboxes and the number of firefighters in the city. Let's first determine if it has a positive, negative, or no correlation. Okay, if we increase the number of mailboxes, do you think the number of firefighters in the city are going to increase? Okay, you could say yes, because you assume the number of mailboxes increases as the number of people increase, which would mean you need more firefighters. So this would make this a positive correlation. Okay, you could also argue a different way, where in this maybe there's no mailboxes. Okay, everyone goes to a post office box or something like that. So it changes. So again, as long as you state your reason, you're going to be okay here. All right, now we need to know if it has a causal effect. Now, in the causal effect, if we add a bunch of mailboxes, are we going to increase the number of firefighters we have? Okay, no, we're not. Okay, so there's no causal relationship. Okay, where it is a positive correlation. Okay, because as the city increases, our mailboxes are going to increase and the firefighters are going to increase. But just because we added mailboxes doesn't mean the city's getting larger and we need firefighters. Okay. All right, have a great day, guys. That's it.